This is video 6.4, the last section of this chapter. And we're going to take a walk down memory lane when you were 3 feet shorter. Think of how old you were and where you were then. And think about when you learned long division for the very first time. So if you had, for instance, 10 divided by 5, which is the same as 10 divided by 5. And you said, how many times does 5 go into 10? And you would put it up here. And then 2 times 5 is 10. So you'd multiply that. And then you draw the line, change the sign, and add. And that was your remainder. And if you had no remainder of 0, you would say 10 divided by 5 is just equal to 2. Let's try another problem. If you had 10 divided by 4, which is the same as 10 divided by 4. So again, you would say, how many times does 4 go into 10? You would say twice. You put it up there. And then you'd multiply. So 2 times 4 is 8. And then you would draw the line, change the sign, and add these together, 10 and negative 8, which make 2. Okay, and then you could, if you were interested in the decimal part of this, you could add a 0, bring it down, put your decimal here so they lined up, and then 4 goes into 20 how many times? 5 times. 5 times 4 is 20. Draw the line, change the sign, and add those. So 20 and a negative 20 make 0, so your answer would just be 2.5. We're going to do it very similar when we have more complicated problems. So I just want to point this out to you. 10 divided by 4 equals 2.5. And if I work this backward, so that's going this way, you could say 2.5 times 4 equals 10. So going backward, it works both ways. Okay, we're going to do synthetic division with polynomials now. And we're going to use the, instead of long division like you just saw, we're going to do the shortcut way. And you did this in Algebra 2, so this is a review lesson right here. So you would take the, this is a factor. So if that's the factor, then the solution would be x equals 3. And that's what we're going to use right here. So we are going to have 3, and there's no variation in how you can write this. You have to write it just like I'm writing it with this format. So first thing we want to do is make sure that this is in descending order in standard form. So we have a 4th power, 3rd, 2nd, 1st, and no power. And we're going to write the coefficients, only the coefficients. So we have 2, negative 17, 51, negative 63, and 27. And we're going to leave a row there. And the first thing we're going to do is bring down this 2. Okay, so then you're going to do multiplying, adding over and over. So you're going to multiply and add and do this loop all over again. So 3 times 2 is 6. And then we're going to add negative 17 and 6, which is negative 11. Then 3 times negative 11 is negative 33. We're going to add, and we get 18. Then 3 times 18 is 54. And then we're going to add, and that's negative 9. And then 3 times negative 9 is negative 27. And that is 0. And this last number, I need it in a box to show that is the remainder. So this is the remainder. Now we don't really know what this is, so we have to go back to putting it into, taking it out of the shortcut way. So this is always the number at the end. This is x squared, x cubed. Notice I did that from right to left to make sure I got these in the right one. So now we just factored basically, pretty much a miracle, right? We took this equation, or this polynomial, and we divide it by a binomial so that we could get another factor. And what this looks like, what this means is that we factored that by x minus 3, and we ended up with x cubed plus x squared plus x, oops, I forgot the numbers, 2, negative 11, plus 18x minus 9. And so what we did is we just factored it. Notice how this was to the 4th power. This is now to the 3rd power. So notice how that brings that down one exponent. So use synthetic division to find the quotient and the remainder. So here it is, right here. We just factored that, and that divides. So if you divided those two out, you would get this answer right here. This is your actual answer. I just wanted to show you the two factors because we're going to move forward with this pretty quick here. So let's take a look at this new one here. So use synthetic division to find the quotient and the remainder. So basically you're dividing again. So again, to set this up here, this here, x plus 1 is a factor, and we need to find the solution, which ends up to be negative 1. So the negative 1 goes over here. And then we have to be really sure that we have every exponent accounted for, and there's some missing ones here. So we have a 1 in front of the x to the 4th. We have no x cubes. Oops. No x cubes, no x squares, no x's, and a negative 1. So those are going to hold the place value. Okay, now we can get started. So we're going to bring down the 1. Negative 1 times 1 is negative 1. We're going to add. Be really careful you do your signs right on this one. Negative 1 times negative 1 is 1. Add. Negative 1 times 1 is negative 1. Add. And then negative 1 and negative 1 is a 1. Add. And remember this last one, we always show it boxed in. Sorry, I don't know why it keeps doing that. I always show that boxed in. That is our remainder. So our final answer here is we just have to convert this back to a polynomial. And this would be the number, the x squared, and the x cubed. So we'd have x cubed minus x squared plus x minus 1. And that is your answer if you divided x squared, x to the 4th minus 1 divided by x plus 1. This is what you would get. Synthetic division is just another way to factor a polynomial, as I talked about on the last screen. So let's try one more here. So if I have this here, and maybe you want to pause the video right now and actually do this one by yourself and see if you got this. Okay, I'm assuming you already paused the video. If you didn't, you're cheating yourself. So I would definitely pause the video if you haven't done this yet. So what goes here is negative 2. And I'd have, this is my x cubed number, my x squared, my x, and my number. So we're going to bring this down, and that's 5. Negative 2 times 5 is negative 10. I'm going to add. Negative 2 times negative 16 is positive 32. Be very careful. And I'm going to add. And then negative 2 and 4 is negative 8. And I'm going to add. I'm going to box that in. And that is my remainder. So if I was going to take this polynomial divided by a binomial, I would get my number, my x squared. So it's going to be 5x squared minus 16x plus 4. And then the remainder is going to be negative or minus 10 over this, x plus 2. So it has a remainder on it. All right. The next problem says determine if the given constant right here is a solution to this equation right here. So what I would do is I would just plug it in. And if you did that, if you plugged it in here, you'd get 1 cubed minus 4 times 1 plus 9 times 1 minus 6. And is that, the question of the day, is that equal to 0? And if you did that, 1 minus 4 plus 9 minus 6 is equal to 0. So is it a solution? Yes. So if this is on the quiz, in order to get this right, you would need to show your work. If you didn't show your work, I'm going to assume that you just guessed this and you're not going to get any points on that. So you have to back up every answer with work. Okay, let's take a look at this one. Is this constant right here a factor, or a solution, I should say, to that? So again, you would plug this in, and you could do this on your calculator. I would on this one. The last one was pretty easy by hand. And you're showing this, so this is your work right here. And that should end up to be negative 10. And negative 10 is not equal to 0, so my answer would be no, but you would be showing this work right here for the credit. You lose a lot of credit if you don't show your work. Okay. Next one says, solve each of the equations exactly in the complex number system. Find one solution graphically. So here's my directions. Find one solution graphically, then divide, and then use the quadratic formula to find your other one. Okay, so let's take a look at this. So on your graphing calculator, go ahead and graph this on your graphing calculator. Pause the video so you can do that. And you should have gotten something that looks like that. So first step is find one solution graphically. And we're going to do that right now in the green. So go ahead and you're going to calculate a 0 if you want. And then you'd have to go left bound, right bound. That's one way you could do it. Another way is calculate the intersection, but then you'd have to have, if you did the intersection, I'll just show that. You would calculate intersection. You would have to have y2 equal to 0 so that there actually is an intersection between the two blue lines. So two different ways. This is one way you could do it. This is another way you could do it. Again, you're showing your work with your graph, just like you do on any quiz. And we end up getting 1, 0. So we know that x equals 1 is one solution. We know that there's going to be actually 3 solutions, all right? So first thing you're going to do is take that 1 and we're going to do synthetic division, divide, use synthetic division to find another factor. So if I did that, I would have, there's my x cubed, my x squared, my x is 0, and negative 3 is my number. Be careful you put that 0 placeholder in. Okay, now I'm going to do synthetic division, so I'm going to bring the 1 down. 1 times 1 is 1, add. 1 times 3 is 3, add. 1 times 3 is 3, add. And this should be 0. We're expecting it to be 0 if that is really at 1. So if this is my number, my x squared, I end up with x squared plus 3x plus 3. And we have that, and then our other factor was x minus 1, right? If I converted this into a factor, because it was a solution. Okay, so I did the second part of this. My third part says, then use the quadratic formula, which you should all know, but I'll go over it. Okay, quadratic formula really quickly is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You have to have that memorized. So I'm just going to put that in a box for you so you remember that. So this is a trinomial. And using the quadratic formula, because this should end up to be 2 factors, right? And we have to figure what those are, and it says the directions say to use the quadratic formula. So if I did that, I'm going to have my A is 1, B is 3, and C is 3. That's my C, my B, and my A. All right, so we have negative B plus or minus the square root of B squared minus 4AC all over 2A. So the work on here, one thing I'm really looking for when you're showing your work is what is this number right here? I'll be checking that on your work. And that ends up to be 9 minus 12, which is negative 3. So we end up with negative 3 plus or minus the square root of negative 3 over 2, which ends up to be negative 3 plus or minus I, the square root of 3 over 2. So here are my other two roots. And I want to go back to my graph here. Just a little number sense here. So noticing that there are 3 roots here, but there's only one intersection on the x-axis. Because my other 2 roots are, so I have 1 real root and 2 non-real roots. And how I found them is I used the quadratic formula to find them. So my final answer here ends up to be x equals my first root, which was 1, and these other 2, which is negative 3, which is simplified, plus or minus I, the square root of 3, all over 2. So this is my final 3 solutions to that equation. Okay, so we solved this equation exactly in the complex number system. And again, it's asking us to find one solution graphically, divide, and then use the quadratic formula. So showing your work for all of those there. So first thing you're going to do is pause this video and get this graph and find the an intersection, an x-axis, on the x-axis. Okay, and if you did that, you would have got a graph like this. And this here would be my intersection. And if you did calculate the 0 and you left bound, right bound it, you would have got negative 1, 0. So we're going to take that, so I'm done with the find one solution graphically. Next, I'm going to go in and do long division. So this is my solution. And then I'm going to line these up. So 2, and you could pause this and see if you could do this all by yourself if you wanted to. Bring down the 2. Negative 1 times 2 is negative 2. Add. Negative 1 and 1 is negative 1. Add. Negative 1 and 2 is negative 2. Add. And you should get a remainder of 0. If you didn't get a remainder of 0, you made a mistake in this number. Okay, so I'm done with the dividing. Next, I'm going to use synthetic division. So this is my number, x squared. So I have, this is the same as 2x squared plus x plus 2. And so this is my A, my B is 1, and my C is 2. So I would have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that ends up to be negative 1 plus or minus square root of negative 15. So again, if you were doing this here, which I would like to see on your test, is negative 15 all over 4. And that ends up to be negative 1 plus or minus I square root of 15. And 15 is just 3 times 5, so there's no perfect square hidden in that, all over 4. So here's my two complex roots or imaginary roots or non-real numbers. And my final answer is going to be x equals this negative 1 here, comma, and then this would be my second one, which is negative 1 plus or minus I, the square root of 15 over 4. And you can kind of guess you're going to have two non-real roots because there's only one real root. So the other 2 must be imaginary because they're not showing up on my crossing the x-axis. Okay, let's take a look at this one. Find all the solutions to the equation. So this one, we see 3 of them. We see -1, 2, and 3. And we know that there are 4 solutions to be had. So we have to find the other imaginary solution. And the only way you know how to do this is by using synthetic division. So -1 is 1 root, 2, 3, and I'm looking for the 4th one. So you could start with any of these. I'm just going to start with -1, and I'm going to use synthetic division to bring this down here to simplify this. So -2, 6, 6, -14, and -12. And if you did synthetic division on that, -1 times -2 is 2. 8. -1 times 8 is -8. I'm going to add those. That's -2. -1 and -2 is a +2. So that's -12. And then -1 and -12 is a +12. Be very careful on your synthetic division. If you did something wrong here, this is the telltale sign here. This remainder has to be 0 because I know that's a root here. Okay, so now I'm going to do another synthetic division. This time I'm going to use, so we use that. And now I'm going to use -2. And I'm just going to keep going here. Bringing that down, that's -2. -2 and -2 is a, oops, that's supposed to be a +2. -2 and 2 and -2 is -4. Add. So that is 4. 2 times 4 is 8, and that is 6. And then 2 times 6 is 12, and that remainder is 0. Again, that's your telltale sign I did it right. And then the last one, which is 3, I'm going to put that right there. And so now I have, oops. Oh, not sure why it's doing that. Stop it. 3 times -2 is -6. Add. 3 times -2 again is -6. Add. So now I end up with, this is my number, this is my x, so I end up with a -2x minus 2 as what I'm left with. So that here, if we find out what does x have to be, we would just set that equal to 0. And we'd end up with a -2x equals a +2 if I move that over. And then if I divide it by -2, x equals -1. So here is my final root that I could not find. Oh, it ended up not to be imaginary. It ended up that -1 was just a double root. So if you want to write it that way, so this here would have been either non-real or in this case, a double root. So my final answer is -1, 2, 3, where -1 is a double root. All right, so this is the last problem. This is an awesome problem, a little bit more complex than the other one. So let's take a peek at this one. So find the exact solutions, which means there's no rounding here, which means if there's a square root of 3, you have to leave it as a square root of 3. I don't want any decimals. Otherwise, you've rounded the square root of 3 because it's an irrational number. Doesn't end, doesn't repeat. So if you put the decimal, you've rounded. Okay, so find the exact solutions is what it's asking me to do. So what do I know how to do? Well, I can find at least one solution by using a graph. So go ahead and graph this right now. Pause the video. All right, so if you've graphed your own here, this should look like this, which ends up to be 1, 0. And if it's true, we know that the remainder will be 0. Okay, and I'm looking for 3, actually. Here's 1. So I don't know if the other ones are either double roots or non-real numbers, but we're going to find out. So here's my 1. And go ahead and do synthetic division on that. If you need to pause the video right now, you can. So we've got our 1, 1, 1, 2, -4. And bring that down. So 1 times 1 is 1, add. 1 times 2 is 2, add. 1 times 4 is 4, add. And I did that correctly. So I end up with x squared plus 2x plus 4. Can't even factor that one because it's, if you were trying to do that. But we're going to use the quadratic formula. So I would have negative b plus or minus the square root of b squared, which is just 4. This will always be a positive number because whatever this number is, even if it was negative and you squared, a squared number is always positive. So just be really careful that that always ends up to be positive. A lot of times I'll just put the square in there because I know how to, it's pretty easy to do that on that one. Minus 4 times a, which is 1. You don't need to write that if it's just 1. So 4ac all over 2a, which is 1. Okay, so let's take a look at this. This is going to take us a little bit of time. So this is negative 2 plus or minus the square root of, and again, you want to find this number, which is negative 12 all over 2. All right, so can that be simplified? It can. So depending on your multiple choice question answers, but the simplified version would be negative 2 plus or minus, and this here, this negative 12, square root of negative 12, this is 4 and 3, and negative 1, if you remember from Algebra 2. So the negative 1 is just the I. The square root of 4 is a 2, and then you have the 3 under the square root still. So I'm going to bring this back over here, and that is going to be negative 2 plus or minus 2i, the square root of 3, all over 2. And again, that can be simplified again because notice we have a GCF on the top of a 2. If I took a 2 out of these two, right there, you'd have negative 1 plus or minus I, the square root of 3, all over 2. And now those 2's cancel out. So I end up with, as my final answer here, I had a 1 up there. Oops. Erase that. X equals 1, comma, and then negative 1 plus or minus, oops, I, the square root of 3. So those are my 3 roots. 2 of them are non-real, 1 is real. Okay, you know what to expect now for your work on your homework to get credit for it. If you don't have work, you're not going to get credit for it, and there's no re-upload. So once you turn it in, make sure you turn it in with your best work the first time because I do not accept a second submission on these. So on all of these here, you're going to find one solution graphically, just like I did in the homework, and then divide and use quadratic formula. So kind of look at what I did in the notes as you work through these problems.